Physics, Part 93. The unit of momentum is the unit of mass times the unit of velocity. That is kilogram meter per second. An alternative unit is the Newton per second. Momentum is like velocity and is a vector quantity. Its complete name is linear momentum. To distinguish it from angular momentum, which does not concern us here, Newton's first law states that every body continues in a state of rest or of uniform motion in a straight line unless acted upon by a force. We can express this law in terms of momentum. If a body maintains its uniform motion in a straight line, its momentum is unchanged. If a body remains at rest, again its momentum zero, does not change. Thus, an alternative statement of the very first law is that the momentum of a particle remains constant unless an external force adds on the particle, as in equation P is equal to constant. There is a special case for a single particle of a very important conservation law. The principle of conservation of momentum, this word conservation here means the quantity remains constant. Newton's second law can also be expressed in terms of momentum. We already have it in a form which relates the force acting on a body to the product of the mass and the acceleration of the body. Remember that the acceleration of a body is the rate of change of its velocity. The product of mass and acceleration then is just the mass times the rate of change of velocity. For a body of constant mass, this is just the same as the rate of change of mass times velocity. But mass times velocity is momentum. So the product of mass and acceleration is identical with the rate of change of momentum. This is the second law, may be stated as the resultant force acting on a body is equal to the rate of change of its momentum. This is the formal definition of the second law, expressed in terms of symbols. F is equal to ma, m delta v divided by delta t is equal to delta mv divided by delta t is equal to delta p divided by delta f. Continuing with the idea of force being equal to the rate of exchange of momentum, the third law relating to action and reaction forces becomes the rate of change of momentum due to the action force on one body is equal and opposite to the rate of change of momentum due to the relation force on the other body. Simplifying this by considering a unit time interval, this becomes when two bodies exert action and reaction forces on each other. Their changes of momentum are equal and opposite. The principle of conservation of momentum. We have already seen that Newton's first law states that momentum of single particle is constant if no external force acts on the particle.